One more prescription drug I want to briefly ask you about with respect to mitochondria are statins, right? So statins are the cholesterol-lowering drugs that many people take. It's known primarily for that role that it plays. What do the most commonly used prescribed statins do to mitochondria, if anything? I've seen some evidence out there that they mess with mitochondrial function, but what do we actually know?
Well, this is another example where people think that they conceive of the side effects as being off target when they're not. So the cholesterol pathway is it has many steps in it, and statins act on the production of mevalonate, which is a distant precursor to cholesterol. Mevalonate gets turned into many other things besides cholesterol. It gets converted into dolichol, which is a important substance for glycosylating proteins, which is the addition of sugars, which is important to their functions. And it's the precursor to the MK4 form of vitamin K2. That's not actually directly synthesized, but when you eat vitamin K1 from plants, you modify it to turn it into vitamin K2 in the MK4 form. And the MK4 form has a number of roles, but one of them is in the mitochondria. It acts somewhat similarly to CoQ10, but not in the exact same way. I think it's kind of an important release valve in the mitochondria, but regardless, it's important for mitochondrial function. And then CoQ10 itself, its tail is made in the mevalonate pathway. And then the precursor to vitamin D, 7-dehydrocholesterol, is also synthesized through this pathway. So you are inhibiting the production of all kinds of things. They include things that are important for mitochondrial function.
So the point is, the mechanism by which they lower cholesterol, it's not just they lower cholesterol, period. There's lots of other things being touched here.
Right. I mean, they're not acting directly on cholesterol. They're acting way upstream from it. So you think you're on a cholesterol lowering drug, and the doctor can call it that, and pharma can call it that, because that's why, that to call it a cholesterol lowering drug is a marketing term. If you were to talk about it in biochemical terms, you would say that it's a mevalonate synthesis inhibitor. If you want to be honest about the biochemistry of it, you're inhibiting the synthesis of mevalonate. That's what you're doing. And that implies that you're inhibiting the synthesis of everything else that is a downstream product of mevalonate, which means that if someone gets myopathy from a deficit of creatine CoQ10, as an example, we know that myopathy is a side effect of statins, but whatever they are, it's probably a result of inhibiting mevalonate. So it's an on-target effect of the statin. It did exactly what you designed it to do, exactly what you wanted it to do, but it didn't do exactly what you told the patient it would do in your marketing materials.
This is how our cells make most of their energy. And in many ways, the modern environment is hurting people's mitochondria in different ways. We've touched on some of those.